continuous. Yesterday I said that limit of a function at a point has nothing to do about the function at a point. This point, the limit for x near this a, the limit always near this region, but this point can go to infinity or go to negative infinity. So now what is a continuous? A function is continuous at a point if first of all the limit exists, secondly that point exists and they are equal. You have three things. If this three thing is true, the function continues at that point. And if you want to write the epsilon delta thing, this is the thing. Your L is exactly your FA. Disagreement with you, counter disagreement with you by saying there's a neighborhood that x near my a, fx converges to L smaller than your disagreement. Nothing new. Prove 2x plus 3 is continuous at x equal 1. My a is 1. So I will have what? X minus 1 smaller than delta. Okay? What is my L here? My L here is F1 because now I have FA. Then I just calculate what's F1. 5. Okay? So you are just proving for any gap you give me, there is a region in X near my A, that is 1, implies my Fx within this region towards the 5, that means my L smaller than your gap. This whole thing and the previous proof is exactly the same thing. I just play with inequality. For example, this step to this step, I'm just divide 2 here. So you can read it by yourself. So you may then wonder, every time we need to prove something, we need to do some tedious thing. Why don't we prove something that is continuous and everybody accept it? For example, a polynomial is continuous. Then how do you prove a polynomial continuous? You just prove this is true for f, and f is a polynomial for any an. This thing equal to this thing because this big bracket is my f. Distribute inside the f. Why? Because each term, the limit exists. Therefore, I can distribute the limit inside, and this is exactly what I want for each of the terms. So this limit thing is c to the power n time. This limit is c to the power n minus 1 time, and it's the same, so I have this. That means I have shown that this thing, limit of a polynomial towards a c, is exactly fc. And this is what? This whole thing is my L, right? How do you prove the function is continuous? I prove L is my fc, then done. That means what? Now this is continuous. Why? Because this belongs to a polynomial. And this whole long chunk of thing is proof that any polynomial is continuous. And this belongs to a polynomial. Therefore, I don't need to write this big chunk of thing. This is before I prove polynomial is continuous. So I need to write this big chunk of thing. This is after I prove polynomial is continuous. Then I just say that, oh, 2x plus 3 is a polynomial. Therefore, it's continuous. Done. Then you can do the same thing by showing that, oh, sine x is continuous. Cosine x is continuous. Log x is continuous. Expx is continuous. Okay? And then, now we're talking about continuous. Basically means limit is the fx. Then we also have this again. What? If fx is continuous, gx is continuous. Of course, they are continuous. And then I multiply constant, it's also continuous. And then I multiply them, it's also continuous. The division is also continuous, given that this guy is not 0. And how do you prove this? Big sentence. Again, no technical detail. You just know this thing exists. And then here, this 2x plus 3, right? This 2x plus 3, the third time. How do I prove 2x plus 3 is continuous? After I use this, I can then name this is my f. This is my g. Since fx is continuous and gx is continuous, so fx plus gx is continuous, therefore this guy is continuous. I can even say that this is my f and this is my g. Both of them are continuous. Some of them also continuous. I can also say this is plus 4 minus 1. Now you see, how do I prove a thing? I have so many ways to prove it. I can prove it by definition, I can prove it by theorem, I can prove it by using property. This kind of degree of freedom, you have so many ways to approach one problem, is where mathematics is difficult and also where mathematics is beautiful. I have a simple stuff, but I have 3 ways to solve this problem. The more method you know to solve one problem, the better you are. The fewer method you know, higher probability you get stuck. So this is why learning how to solve a problem with different method is important. What is this? I'm saying that I have fu and then u is fx. I need to say that fu is continuous and the limit of g exists at this point. Otherwise, if this guy does not exist, then I have an f question mark. So I cannot say anything. If these two are true, I can put my limit inside. Before I say this, I cannot say, oh, I put my limit inside. Because I didn't prove that limit before and after the square root is the same thing. Now I can say they are the same thing. And how do you prove this is true? You prove a big chunk of epsilon delta thing, which is 1 page long. How do you prove Ex is continuous? Ex is just a particular point at A, but a small change is the same as H go to 0. Then this is what I have for the product. This Ea is just constant. I take it out. So I need to prove this thing. This thing is 1, so it's Ea. So it is limit of fx is a L. L is FA, so this is continuous. And you can do the same trick on how to prove sine cosine. And again, now I have this 2x plus 3. This is the fourth time we see this. How do you prove this guy is continuous? Gx is 2x and hx is x plus 1. Now I'm going to use a composition. That means my fx is composition of h and g, which is what? Hx inside is gx. And since gx and hx are both polynomial, therefore each of them is continuous. And this limit exists at 1, therefore this guy exists and therefore continues. Lastly, the fifth way, left limit equal right limit. Suppose I want to prove a limit exists in FA. I look at h go to a from the left and x go to a from the right. Prove them they are equal. And why this is true? Because the epsilon delta definition can give you this. That means what? From this big chunk of thing, I can give you these two sentences. How? Okay, another bunch of proof. Don't need to read. Just know that this is true. So this gives you the fifth way to prove limit exists. So let me try to recap everything. How do you prove limit exists? This is the source of the evil of everything. How do you prove a function is limit exists? You prove this sentence. How do you prove the function is continuous? You prove this sentence is true for L equal to that particular point, FA. Okay? And then because of this, it leads to the following. You can now have squeeze theorem. So if you want to prove this guy exists and you have very hard time to prove this thing, you find a lower bound and an upper bound and squeeze them. Okay? Or you try to express this f as some simple function. And which for the simple function, the component, you know they exist or it's easy to prove. Then you use the composition or polynomial to prove it exists. So these are basically the three ways. You prove by definition, you prove by squeeze theorem, and you prove by construction. That means you use simple stuff to build bigger stuff until you reach what you want.